Next, we're going to take a look at factoring. We'll start with just factoring a constant, the number 24. When we want to factor it, it means that we want to find something that multiplies to 24. So in the example where we did 30 just a few minutes ago, we did 1 times 30, 2 times 15. We had lots of answers. To get a prime factorization, we're trying to get just one answer, and we want the numbers that are part of the product to just be prime numbers. So we'll start off by making a factor tree, and we'll take 24 and we'll break it into maybe 2 times 12. 2 is prime, so I'm going to circle it. 12 is not prime. That is 3 times 4. 3 is prime, but 4 is not. So I keep breaking down the factors as far as I can until I just get prime numbers. So 24 has 1, 2, 3 factors of 2 and 1 factor of 3. I can leave it written like this, 2 times 2 times 2 times 3, or I could also rewrite that as 2 cubed times 3. So I've got this 2 times 2 times 2 that I could rewrite as 2 cubed if I like. In a moment, we're going to be multiplying things that are a little bit more complicated to come up with monomials instead of just a plain number. So the monomial is going to add some variables to the expression. A monomial is an algebraic expression with just one term. Specifically, that term is the product of numbers and variables. And any variables have to have a whole number exponent. So here's a whole lot of examples. The column on the left, those are all monomials, and the column on the right, those are not monomials. So if we look at the definition, we said it could be a plain old number, it could be a plain old variable, or it could be the product of a number and a variable. Now with the exponents, this n squared, for example, could be written as n times n, so it is the product of variables. And notice that we said the exponents have to be whole numbers. So 0, 1, 2, 3, no negatives, no decimals, no fractions, no variables. Now when we move over to the other column, we find things that go against this definition. Here's the first one. We said it could be the product of numbers and variables, not the sum of products and of numbers and variables. And we also said that all of the exponents must be whole numbers. And if we look at these exponents here, those exponents are not whole numbers. Some of them are integers, some of them are rational, some of them are irrational. So that is what makes those not monomials. We'll do one last example here, factoring a monomial. And if you look at this, it looks similar to the one we did at first, but with variables at the end. We're going to start off the same way. We're going to take the 27 and we're going to break that down into a prime factorization. So 27, when we do the factor tree with that, we come up with 3 times 3 times 3. X, remember if there's no exponent, that means it's an x to the first. Y cubed means y times y times y. So this is one way that you could write your answer, or if you wanted to do it a little bit more efficiently, you could change the 3 times 3 times 3 into 3 cubed, and the y times y times y into y cubed. Both of those are good answers though.